Next, we will discuss about graphical representation of linear motion. Okay, what is linear motion? That we have learned in the previous part, that is motion in one dimensionally is basically linear motion. So graphical representation, before learning about graphical representation, we have to learn what is graph. Okay, so what is graph you have already learned in mathematics, but here we will learn little bit more. Graph is basically a geometrical relationship between two physical quantities which are interrelated with each other. Okay, so it is relationship or geometrical relationship between two physical quantities which are interrelated. Okay, so to draw a graph, what basic things are needed? Now, to draw a graph, we need two axes. Okay, so two axes are needed. One is x, another one is y. Okay, one is x, another one is y, and here the intersection point is known as origin. So along x-axis we have taken that quantities which is independent, variables. I have already told that geometrical relation between two physical quantities. So one quantity we have to take along x which is independent, which doesn't depend on the other physical quantity, and here second axis, along second axis we have to take dependent variables. Okay, so along x independent, along y dependent variables. Then the next work, what we have to do, the next work is the scaling. So along x and along y we have to make scaling. Okay, so along x we have to take scales and on y we have to take scale. Okay, now the graphs we are going to do now, there are three graphs are there. Number one, displacement time graph. Number two, velocity time graph. And number three, acceleration time graph. So these three graphs we will just learn now. Okay, so what is the first one? Displacement time graph. Okay, so what is displacement time graph? Now where we are taking two physical quantities, one is displacement and along is one is time. Okay, so time we have to take along x-axis because it is independent variables, because time doesn't depend on anything, and displacement it depends on time. Okay, that's why we have to take it along y-axis. Okay, so time displacement. Okay, so time we have to take it is in second, and displacement is which have to take in meter. Okay, now the first condition we have to take here, that is if the body is static. If the body is static means it doesn't change its position. Okay, now we have to show you the graphical representation. Time and second we have to take the data. So as it is static, we have to take 0 1 2 3 4. This is the time axis. Along time axis we have to take this scaling, and along displacement we have to take, assume the displacement is same because it is static, it is not changing its position. So assume it is 20. So it is 20. Okay, let's see. So 1 2, 3, 4, 10, 20. Okay, so along x-axis I have taken time, that is 1 second, 2 second, 3 second and 4 second, and along displacement it is 10 meter, 20 meter, 30 meter. So first, when we are starting our observation, then it is static, it is 20 meter. Okay, and now in 1 second it is also in 20 meter, in 2 second it is 20 meter, in 3, in 4 second that is also 20. Means every time second it is not changes its position. Okay, so the graph will be like this. So it is parallel to x-axis, so the displacement, so in displacement time axis, if we have seen so parallel to x-axis in any portion, that means here the body is static, here it is doesn't change its position. Okay, so that is a graph of a static body, the displacement time graph. Now we'll go for the next graph, that is point B, that is uniformly increased displacement. So here also we are taking some datas, that time and displacement is time, it is 0, 1, 2, 3, 4, 5, and the displacement assume at 0 the displacement is 0, in 1 the displacement is 10, the 2 displacement is 20. So displacement should be in meter, time should be in second. Okay, in 3 it is 30, in 4 it is 40, and 5 it is 50. Okay, so see, uniformly the displacement is increased. Initially it is increased by 10, and you see every 1 second it is increased by 10 meter. Okay, now if we draw it in a graph, so along x-axis we have to take time in second, along y-axis we have to take displacement in meter. So it is 1, 2, 3, 4 and 5. 1, 2, 3, 4, 5. So we have to take the observation for 5 seconds. 10, 20, 30, 40 and 50. And now you see, whenever we have seen the exact starting, that means the time is 0. Time 0 means it is the starting. So here the displacement is also 0. In 1 second you see the displacement is 10, so it is coming here. In 2 seconds the displacement is 20. In 3 seconds the displacement is 30. In 4 seconds it is 40, and in 5 seconds it is 50. Okay, so we have to take the data for 5 seconds, so it is 50. See, these are the points. So if we connect it, it will be a straight line along origin, and the graph and the line, the straight line we have seen, it is increased. Okay, it is increased, that means the displacement is increased with respect to the time uniformly. Okay, if it is not increased uniformly, so if it is non-uniform, then the graph should be a little bit of different. So it is if I'm taking a data like this, assume it is 0, 0, in 1 it is 10, in 2 assume it is 30, in 3 assume it is 50, in 4 assume it is 60. Okay, like this if it is increased. So it is, see, it is not uniform. Here it is increased by 10, here it is increased by 20, here it is increased by again 20, here it is again 10. So it is not uniform. So how does the graph looks? It is 1, 2, 3, 4, 5, it is 10, 20, 30, 40, 50, and assume it is 60. Okay, it is displacement, that is s in meter, and it is time in second. So in 0 starting it is 0, in 1 it is 10, so it is here, in 2 it is 30, so we have to draw a perpendicular from 2, we have to draw a perpendicular from 30, so it will come here. In 3 it is 40, 3 it is 50. Okay, in 4 it is 60. Now we see it is not a straight line, it seems to be looking like this. Okay, it is increased like this way. So if it is increased uniformly, then it is a straight line. If it is increased non-uniformly, then it will be a curve. Next, if it is decreased, uniformly, then what will be the graph? So if it is decreased uniformly, so assume if a data is taken here, that is 1, here I have not written now. Okay, I think you can able to understand this one clearly. It is assume 10, it's 20, it's 30, it's 40, and assume it is 50. Okay, so here it is displacement s in meter, but time in second. Okay, so initially assume the velocity is 50. I'm sorry, the displacement is 50. Now in 1 second assume it is 40. In 2 seconds assume it is 30. See, it is uniformly decreased. In 3 it is 20, and in 4 it is 10, and in 5 it is 0. So then the graph will be looking like this. Here also it is a straight line, but it is coming downward. It is uniformly decreased up to 0. Okay, so it is a graph, a displacement time graph, where we have shown the displacement is decreased uniformly. Now if the displacement is decreased non-uniformly, so definitely if it is a non-uniform displacement, so it shouldn't be a straight line. Assume it is initially here. If it is just decreased non-uniformly, it must be a curve. Okay, it will coming like this. So here I am not taking any data because I think you can able to understand. It is not, it will not be a straight line. Assume it is increased uniformly and decreased also uniformly. So if we show it is uniform, increase and decrease. So here we are just showing a nature graph. Nature graph means we are not taking the scale. Okay, we are not taking the scale, we are just seeing the nature. So if we want to show a nature graph, so it will uniformly increase. Okay, uniform increase and then decrease, uniform decrease. Okay, OAB. So OA shows uniform increase and then OB is uniform decrease. Okay, so is it clear? Now we'll go for it is non-uniform increase and then decrease. Okay, okay, so it is increase uniformly and then it is decreased. Okay, see, it shouldn't be a straight line. I think you can able to understand the thing whole. Okay, now we have to find out the displacement time graph, what we can able to calculate. So calculation from displacement time graph, calculation from displacement time graph. See, from any graph, what basic things we can able to calculate? Let's see first. So first one we can able to calculate from it, it is the slope. Okay. What is slope? You have to learn it first. So slope is an angle between the graph and x-axis. So it is angle between graph and x-axis. Okay, so what is the angle and how we can able to measure it? Let's come. So assume this is a graph, whatever it may be, a graph, it's x and it's y. Assume the graph seems to be looking like this. So the angle is made by the graph with x-axis. Assume it is theta. That measurement of the angle is your slope. And now the problem has come, how can we able to measure it? For that case, we need to get an idea of trigonometry. The trigonometric identity, I think you have not learned yet, but you will learn it. So what trigonometry tells us? So trigonometry tells us about the right angle triangle. Okay, so if it is a right angle triangle, what it is, that is ABC, and if the angle is theta, then we have just learned three trigonometric identities. First one is sine theta, which tells us the perpendicular by hypotenuse. So it is clear, if it is theta, so this one is the perpendicular and this is the hypotenuse. So perpendicular AB by hypotenuse BC. Cos theta, so it is base by hypotenuse. So base is AC and hypotenuse is BC. And tan theta, which one is very much important for us now, it is perpendicular by base. So it is AB by AC. Okay, here in this slope calculation, we have to find out tan theta. What is tan theta and how we can able to find out? So assume it is O, it is A. So from A point we have to draw a perpendicular at the point B on x-axis. So it is also a right angle triangle. So here the angle is theta. So from here, if I want to find tan theta, tan theta is equals to AB by OB. AB by OB. AB is the perpendicular, OB is the base. Now we have to find out theta and we are finding tan theta. So how we can able to get theta? Now there is a condition that if theta is small, then tan theta is equals to or nearly equals to theta. So which one is tan theta? That can be taken as theta if the theta is small. So theta equals to AB by OB. Now this idea we want to use in displacement time graph. So assume we have drawn a displacement time graph. Along y-axis it is displacement in meter, along x-axis that is time in second. Okay, so assume the displacement time graph, it shows the displacement is increased uniformly. So it is your displacement time graph. So assume it is O, assume it is A, and now here is your perpendicular. Now if it is B, so along OB what we have taken? We have taken time, so time is T. Achha, along BA, this perpendicular, if I have drawn another perpendicular from A to here, it is C. So we can say that OC equals to BA because this length is same. So along OC, what things are changed? It is displacement S. Okay, so if I have told you have to find AB by OB, so it is basically S by T, that is displacement upon time. So displacement by time equals to velocity. And AB by OB, just now you have learned, that is slope theta. So slope theta is equals to velocity. From that we can able to conclude that the slope of displacement time graph with time axis gives us velocity. Now one question comes to your mind. Sir, if it is a straight line, then it is not a problem to finding out the velocity. But assume if it is increased non-uniformly, it is T, it is S. So if it is increased non-uniformly and we want to finding out the velocity, then how we can able to find out? See here, the displacement is increased non-uniformly, so velocity is also changed in every point. Assume it is told you have to find the velocity here in this point. Assume this point is A. Then how we can able to find the velocity? We have to draw a tangent in the point A. Okay, so as the tangent is drawn, if I draw a perpendicular here, I can able to get the value here. Okay, the time axis. From here also we have to draw a perpendicular. You will get the value. So assume it is T1, it is T2. From here we will draw another perpendicular. Assume it is S1, and from here we have to draw another perpendicular. Assume it is S2. Okay, so this is the displacement changes at point A as the time changes. Give name here. It is B, it is C, and draw a perpendicular here. It is D. So from here we can able to find out the theta. So theta means this angle. So theta is equals to what? Perpendicular DC by base BD. So DC equals to what? S2 minus S1. What is BD? That is T2 minus T1, and that will also give delta S by delta T. Delta S means change in displacement, delta T change in time, which is also velocity. So here also we can able to find out the velocity at point A. Okay, so by finding the slope of a displacement time graph, we can able to find the velocity. Okay.